Broadcasting. Okay, it looks like people are starting to join into the webinar with us. Hello and welcome to our first webinar of today. And today we're going to be talking about animals of long ago. We're going to be going through the Heron Books course that they have put together on this awesome subject. There we go, full screen. I'm James.
And I'm Diego.
And today, as I said, we're going to be going through animals of long ago. When you registered for this webinar, you would have gotten an email, or your parent would have gotten an email with the link to this book and to the learning guide that goes with it. And we're going to go through this together. Let me pull up the workbook for us. Here we go. Okay, Diego, why don't you take us away through the first chapter?
All right, animals of long ago. Let's begin. So we're on chapter 1. If you're there following along, great. Earth is about 4.5 billion years old. It's been here for a long time. To get an idea how long, imagine counting, saying a number every second. You would have to count on and on without stopping, second after second, number after number, for over 100 years.
I just got to 10.
From the beginning, the Earth has been changing. For a long time, it was very hot and it never rained. We think that for the first couple of billion years, nothing lived on Earth. Then the Earth cooled off. For several 100 million years, it rained almost every day. Living things began to appear. Later, most of the Earth became covered with ice. This went on for ages too. You can see that over time, the Earth changed a lot. Gradually, the Earth became home to many animals. Some of these are no longer here. As Earth changed, it became too hot or too cold or too wet or too dry for them. When an animal dies off and not one of that type of animal is left on Earth, we say that kind of animal is extinct. But many animals are still here. As the Earth changed, they did too. They might look different now from the way they did long ago, but they're still here. Millions of years ago, horses were only a foot tall. Gradually, they changed. Today, they are bigger, stronger, and faster. Those are some big changes, huh?
Look at that. So over there on the left of the screen, that was a horse 55 million years ago. That was a horse. It's the size of a dog.
Yeah. Wow.
And now we can ride them.
Yeah, it has some spots that kind of look like a deer, huh?
Yeah.
All right. Animals didn't change all of a sudden. Like magic, it was very, very slow. Change that took millions of years. They changed in ways that helped them stay alive and be safe on the changing Earth. Some animals got bigger and some got smaller. Some grew fur and others got sharper teeth. Some grew wings so they could fly. Some moved from the water to live on land, and others moved from land to live in water. Today, there are many kinds of animals alive on Earth: fish, birds, reptiles, horses, lions, tigers, hippos, giraffes, and so many more. They're here because they changed as the Earth changed. They may be different now from the way they started out, but they're still here.
Now, these two pages, I'm going to toggle back and forth here so we can see the difference. So if you look at the duck on the top left of that page there, and then we look at the duck that we see down there today, that's a duck that we all recognize. That large bird in the middle kind of looks like an ostrich or an emu or something like that. You can see it still has arms reaching out, longer arms. And there's our ostrich of today. The arms have tucked in their wings because, they're not flying. You see a big fish in the background there, big chompers on him. And there's a fish of today. It looks like it got quite a bit smaller through evolution. And there's a little rat.
Mm-hmm.
And there's a rat that we recognize. All right, there we go. Okay, so that gets us to the end of chapter 1. there are some awesome activities here, as you can see on the screen. Draw a picture of what the Earth might have looked like millions of years ago after it cooled off and rained almost every day for years. Show which animals would live well in that kind of weather. These activities we're not going to go through together here today because there's a lot of drawing and coloring involved. I want you to take the time to do those drawings, or paint them if you want to. Take the time to do those and really really fill in some details on them. We're going to keep reading along here, but I would love if you guys did that at home and showed it to your parents. If you want to take some pictures or scan them and email it into us, events@delphian.org, and I'll repeat that at the end of this webinar. Then we can see some of the pictures that you guys put together.
Perfect.
All right, let me pop into the Q&A and see. So as with the past webinars we've been doing the last few weeks, if there's anything you want to say, if you have any questions, feel free to put them into the Q&A, the question and answer box down there at the bottom. Mariah says, hi. Keely says, I'm Keely. Hi, Keely. Mm-hmm. Welcome. Hello, Sophia and Ellie. I'm so glad that all of you are able to join us today.
And also, too, we're going to be looking at some fossils.
Yes.
So we have some.
We've got a bin full of. Oh, this is heavy. Yeah. Fossils are heavy. We got all kinds of stuff. We're going to be looking through all of these at the end of the webinar today.
A lot of really cool samples.
What's that one? That one's big.
Yeah. You want to see this?
Yeah. Here, pull it over.
Take a look at this.
I'm really curious what that is, but I guess I have to wait.
Should we tell
a little
now?
bit? Yeah, let's tell them. Let's tell them.
Okay. This is a mammoth tusk. This was found at one of our former staff members' house. It was Barb Silver. Mm-hmm. Yeah. And this was found in Northern California. They were excavating for a project they were doing. And that excavate means to dig up the dirt. And they had to stop digging up because they found a woolly mammoth buried under the ground there in Northern California. And this is not a copy. This is the actual thing. I'm holding right now a woolly mammoth tusk. And you can see it kind of looks like there's rings. You can see some of the texture of how the tusk was formed, some of the cell structure. And how
this is bone.
This is bone, yeah. This
wow.
is just a giant tusk
from thousands, tens of thousands or more years ago.
And this sits in our lab. We have pretty awesome, amazing. What do you call it? Fossil.
Yeah.
We have tons of fossils.
Fossil collection.
A fossil collection that we have, and as kids do the course here at Delphian, they go through and actually look and touch and see some of these things. So very, very cool.
So we got a lot more of those that we're going to look through near the end of the webinar today. A lot more people saying hi in the Q&A box. Hello to everyone. I'm sorry if I don't answer each of you individually here. Sophia did say that she was late. Why and how do these animals change? So for those of you who joined us a few minutes late here, that's totally okay. I'm going to go back to a slide we were looking at a moment ago. We're going to be talking about dinosaurs next. I love dinosaurs. Here's a picture of some animals from many millions of years ago. And here is a picture of some of those animals today. And you can see differences. We'll look at the rat, for example, at the bottom there. That's what a rat looked like 125 million years ago. And down at the bottom of that page, you can see what a rat looks like today. And those changes happen very slowly, one generation at a time, very slow changes over the course of millions and millions of years. And we're going to get a little bit more into detail about that. Chapter 2, dinosaurs. Okay, let's see, I think I'll go along on the screen here.
Okay.
Dinosaurs are animals that lived long ago. They have been extinct for 70 million years, but are fun to learn about. Dinosaur means tremendously huge lizard. But most dinosaurs weren't actually lizards. Sir Richard Owen, who invented the name, studied some enormous bones that had been found. He could tell they were from animals that were gigantic, and he thought they might be lizards. So now we use the name dinosaur for a large number of different reptiles that once lived on Earth. What is a reptile? Reptiles are animals that have backbones, large or small scales on their bodies, no fur or feathers, and hatch from eggs. Turtles, lizards, snakes, alligators, and crocodiles are all reptiles. The dinosaurs were too. Some dinosaurs were gigantic, more than 100 feet long and taller than a 3-story house. Others were smaller than a chicken. Some dinosaurs were meat eaters who hunted alone or in packs. Dinosaurs lived all over the earth. It was just the way they liked it, nice and warm. They lived on land, but some liked to hang around swamps, marshes, and lakes where food and water were easy to find. And you can see there's big tall ones and there's little ones at their feet, and you can see some dinosaurs hatching out of eggs there in the background. Okay, so that covers chapter 2.
James.
Yes.
I have a dinosaur fossil here.
Ooh.
Yeah. So
let's see it.
This is, let me show you what it is. Go ahead and take a look at that. Now, how on a scale of 1 to 10, how hard does it feel to you?
This is hard. This is a rock.
Okay.
Yeah, it's not the hardest rock I've ever felt, but that's definitely solid.
Yeah, and see if you can smell any odor in it at all.
No, smells like a rock.
This is called a corpulite.
What does that mean?
Corpulite is dinosaur poop. So this is from our sample.
Thanks, Diego.
So our senior lab instructor Marty Shaw played the same joke on me. So
make me feel a little bit better. And the people watching, how old is that? How many millions and millions of years old is that?
This, I don't have a date on it on the sample, but I'm guessing if it's dinosaur poop, it's probably around 20 million years old. There's textures
or more, like
yeah.
maybe at least 70. I think the book here was saying they've been extinct for about 70 million.
70 million. Okay, so we're up 70 million. So
yeah,
millions of years old. Very old. So you're safe, James.
Yeah, the Q&A section is very much enjoying that trick.
Okay.
I thought April Fool's was yesterday. All right. All right. Ellie asks, were humans alive back when there were dinosaurs? Good question, and no. And I'm pretty glad for that because as it covered in the chapter, some of these dinosaurs were huge. They were humongous. The atmosphere on the Earth in those days was a little bit different than it is now. There's a lot more oxygen in the air, and just the temperature of the earth at that time, what was in the air at that time, it allowed animals to grow bigger. And as the temperature changed over time, as the atmosphere changed, animals grew a little bit smaller because they needed to. You know, you could survive better if you were not the size of a 3-story house.
Yeah. And we continue to learn. We continue to learn more and more things all the time. Just in 2017, some scientists were doing some core samples in Antarctica, and they found stuff that was they found evidence that Antarctica was once a swampland about 50 million years ago. So these things are, you know, as people continue to dig and find more samples, it's like putting together a giant jigsaw.
It's a huge jigsaw puzzle.
Yeah.
A jigsaw puzzle that you have to piece together through time, because you not only have to see where did you find that thing, and what could it be, and what other bones around there does it fit with, but how long ago was it?
Right.
You could find 2 bones right next to each other. One's from 70 million years ago, and one's from 300 million years ago.
So true.
It's fascinating.
So true.
Okay, we're going to move on to the next chapter here.
This me?
Yeah, and again, there's some really outstanding activities listed after every chapter. So do download this book and this learning guide from the email that you received when you registered for this webinar. and take the time to do those activities at home. We're going to carry on.
All right, chapter 3. Most dinosaurs ate plants. Some plant eaters grazed in big herds like cows do today. A huge plant-eating dinosaur was Brontosaurus. Brontosaurus means thunder lizard. The man who named the Brontosaurus thought it was so big that it must have made a noise like thunder.
That makes sense.
Yeah, a Brontosaurus was about 70 feet long and weighed 15 tons, or 30,000 pounds. This is about the length of 3 elephants standing end to end and just about as heavy. Some people think Brontosaurus protected itself from attackers by using the end of its long tail as a whip. This may have made a loud sound like a cannon being shot off. People used to think Brontosauruses lived in the water most of the time because they were too heavy to walk much. Now we know they had very strong legs and teeth made for eating tough leaves and branches that they could reach with their long necks. Another enormous plant-eating dinosaur was Brachiosaurus. Brachiosaurus means arm lizard. The dinosaur had very thick front legs that were longer than its back ones. It's hard to imagine, but Brachiosaurus was even bigger than Brontosaurus. A tall man could walk under a Brachiosaurus and his head wouldn't even touch its stomach. Brachiosaurus was almost 100 feet long and is believed to have weighed 60 tons or 120,000 pounds, as much as 12 good-sized elephants. With their necks straight up, Brachiosaurus were 40 feet tall and could have easily peeked over the top of a 3-story building.
That's taller than the school here.
That is. It's amazing. With their long necks, Brachiosaurus probably reached up and ate the tops of trees like giraffes do today. They could, however, reach much higher than a giraffe. Another strange-looking plant eater was Stegosaurus. Big, stiff armor-like plates grew along its back, and long spikes grew out at the end of its tail. Stegosaurus could fight off enemies by swinging its spiked tail right at them. Like an elephant, Stegosaurus was about 20 feet long. Its head, however, was tiny, with a brain only about the size of a walnut. Triceratops was a large horned dinosaur. Triceratops means 3-horned face. Triceratops used its horns to protect and defend itself against larger meat-eating dinosaurs who would have liked to make it into a meal. It was about the size and weight of a large elephant. Maiasaura means good mother lizard. Because it is the only dinosaur known to have cared for its young in nests. Maiasaurus were over 30 feet long and lived on twigs and leaves. They are called duck-billed dinosaurs. Can you see why?
Because it has a bill like a duck.
Yeah.
Okay, so again, great activities here. Feel free to do those at home. Let's look at, okay, Q&A is going here. All right, so Cypress asked, then wouldn't people grow bigger? Cypress, I think you're referring back to something I was talking about a few minutes ago, where a lot of things grew bigger because of how the Earth was at the time, how warm it was, what was in the atmosphere. I think if humans were around there at that time, I wouldn't be surprised if we were a little bit bigger than we were now for those reasons. But that was, we're talking at least 70 million years ago. Humans that look like this, and as we know them, didn't come about until a few tens of thousands of years ago, much more recently. Why did yes?
And on that note, we have a
yes
special item in here. This is the cast of mandible of Keniapithecus.
Mandible is like part of the jaw.
Yeah, the jaw. Keniapithecus africanus, believed to be the oldest known true ancestor of man, circa 20 million years. And this is from Russing Island in Kenya, down by the equator. So you can see that this is the mandible.
Wow, look at those front 2 teeth really sticking out there.
And it looks like, yeah, you can see.
You could probably really use that to, tear some meat off of a hamburger.
Yeah, this thing is pretty, but this is believed to be an ancestor of modern man. 20 million years.
Yeah. All right, going to catch up on some questions. Why did some dinos have beaks? Good question. Why do some ducks and other animals have beaks today? Because it helps them eat the food that they eat. I think if you're eating, plants in water, have you ever tried to grab something in water and as you try to grab it, it kind of moves away a little bit? I think having a round, kind of a wide beak like that allows you to easier grab plants in the water and eat them. That's my guess on it. Yeah.
Yeah.
Amelia asks, hi, Amelia. She asks, what is this book called? This is the Animals of Long Ago course. And yes, there we go. All right. Wow, so many questions. I'm so sorry that I don't have a chance to get to everything here. Sarah asked, what was the tallest dinosaur ever? That's a good question. If I had to guess, I'm thinking that the tallest one was one of the ones that we talked about just a few minutes ago. I'm gonna go back here. The Brachios. Let's see, what was the other one?
Yeah, you have the Brontosaurus.
Yeah, the Brontosaurus and the Brachiosaurus, which I'll go back to here for just a moment. There we go. There's the Brontosaurus, 70 feet long. And here's the Brachiosaurus, 4 stories tall.
Yeah,
I
don't know of another one
3 or 4 stories tall. Neither do I. I have not personally met a dinosaur taller than that. Yes.
Lots of questions. Thank you for the questions.
Yes, some really good questions here. Do some dinosaurs eat eggs? I'm sure that some did. Eggs are a great source of protein. I ate eggs this morning. And if you're the type of animal or dinosaur that doesn't eat only plants and that eats meat, which we're going to talk about in a moment, I'm sure a nice tasty egg would be something that you would really look forward to. Milo asked, what killed the dinosaurs? We're going to talk about that in a couple of chapters. Okay, moving on to chapter 3, meat-eating dinosaurs. I did on purpose arrange it so that I would read this chapter.
Oh yeah, you got a cool one on this.
There we go. All right.
Treat.
There were always more plant-eating dinosaurs than meat-eaters. Some of the meat-eaters were small, about the size of a man. Small, size of a man, okay. They often hunted in packs. Others were much larger and hunted alone. One of the bigger meat-eating dinosaurs was Tyrannosaurus. Tyrannosaurus means tyrant lizard. A tyrant is a cruel ruler who makes everyone do things their way. The person who discovered and named Tyrannosaurus thought this huge meat eater was so fierce and strong that it ruled over all other dinosaurs. That makes sense. Tyrannosaurus was one of the largest meat eaters that ever lived. It had a huge head, long, sharp teeth, and large, powerful hind legs. Its front legs were small but still strong, with 2 claws at the end. Tyrannosaurus was 40 feet long, longer than 3 elephants in a row. And you can see on the page there kind of a little outline of a man. I am so glad that we did not exist on this planet at the same time as that guy. Yes. Another large meat eater was Allosaurus. I always mispronounced that one when I was younger. Allosaurus. This dinosaur liked to feast on Brontosaurus meat, but a whole herd of angry Brontosauruses was too much to attack. Instead, Allosaurus probably looked for young or sick animals. This is the way lions and tigers hunt today. It's hard for them to catch healthy, grown plant eaters like buffaloes or wild pigs, so they usually go after the young or sick animals instead. And Allosaurus was 30 feet long, almost as long as Tyrannosaurus. Okay, again, some great activities here that you guys can do at home. All right. Let's see, a lot of people ate eggs this morning too. Great. Did they eat raw eggs or cooked eggs? They would have been raw. You got to use fire and stuff to cook. Humans are the only animals that eat cooked meat. All the other animals eat it raw. Why did some animals survive when the dinosaurs all died? Kamuro, I hope I'm saying your name right. Great question. I think we're going to talk about that Death of the dinosaurs in the very next chapter here, or the one after that. Kiosha, would a meat-eating dino eat its own type? You're coming up with some good questions here. I think if given the choice, it would rather eat a plant-eating dinosaur. If it absolutely had to, I wouldn't be surprised if it did eat one of its own type. Yep. All right.
Great questions.
So many good questions here. Tyrannosaurus equals T-Rex? Yes. Tyrannosaurus or Tyrannosaurus Rex is what it's called. We call it T-Rex for short because it sounds awesome. Wow, you guys know a lot about dinosaurs here. I'm so sorry I don't have a chance to say everything here. Nathan says the biggest dino is Argentinosaurus. Well, now you know it's big. There we go. Yep, Nathan chiming in with that fact there. Okay, we are gonna move on. You guys are great here. Let's see. I'm keeping an eye on the time to make sure that we move fast enough that we can look at these fossils at the end for a few minutes.
Yeah.
All right. Take it away.
All right, chapter 5. Dinosaurs walked the earth millions and millions of years. 160 million. In fact, that's a long, long time. Then suddenly they all died off. Today they are extinct. What happened? We're not sure exactly. Something happened millions of years ago that made all the dinosaurs and many other animals die. Scientists agree that there was some sort of huge earth-changing disaster, but they don't know for sure what it was. Some scientists thought a disease spread around and killed off the dinosaurs. Others think an enormous meteor about 8 miles wide suddenly hit the earth. The collision would have been stupendous, as strong as the explosion of 1 trillion tons of dynamite. It would have caused gigantic earthquakes, wildfires, tidal waves, floods, and huge clouds of rock dust that lasted a long time. Other scientists thought the earth grew colder for some reason. Plants could no longer grow. The dinosaurs, who were used to living on an earth that was very warm, could no longer find food, so they died of starvation and cold. Whatever happened, the earth became unfit for dinosaurs to live on, and they are no longer here. Scientists have tried to find proof of exactly what happened. They are still trying and are still learning more and more about dinosaurs and how they lived and died.
Okay, the chapter 5 activity here is talk to another person about how the dinosaurs may have died. Find out if they have any ideas of how and why this happened. All those examples, all those possible scenarios that it talks about there would make sense. If a big meteor did hit the Earth, then I imagine that would also lead to it getting really cool, leading to a mass die-off like that. If you're further interested in this, feel free to continue to study this subject, grow up, become a geologist or a paleontologist. We're going to talk about that word in a little bit. Someone who digs up and studies fossils, studies animals of long ago, and maybe you'll find a clue that helps solve this question. Let's see. Someone was worried that there was 4 minutes left. We're going to go to 9:45 today, so we've got 16 more minutes at this point. So we're definitely going to leave some time, make some time at the end for these fossils. I heard a possibility that a volcano may have erupted very violently and caused a huge change that made the Earth colder. Sarah, that's a good point. That's very possible. Back in the 1800s, there was a large volcano that erupted here on Earth called Krakatoa. It erupted so violently and put so much dust and ash into the air that year was known as the year without summer because it was not super cold. It wasn't snowing in the summer, but it was colder than normal. So if that could happen from a volcano erupting, just 100 or 200 years ago, if it was an even bigger eruption, or if several volcanoes erupted all around the same time, that's very possible. Okay. Where did our animals come from? Let's see. When the dinosaurs suddenly disappeared, most of the other animals on Earth did too, but some remained. There are still a few reptiles, alligators, and crocodiles, and some fish. There were also birds, frogs, and salamanders, and some furry mammals. As time passed and Earth continued to change, many of these animals also began to change. The changes were very gradual. Maybe their legs began to get a little shorter, or they grew a few feathers, or their tails got a bit shorter. Slowly, very slowly, over a long period of time, they became less and less like the animals they had been when the dinosaurs died. They became more and more like the birds and mammals we have today. As the Earth changed, these animals changed too. And you can see, let's see, there's a bird there. I don't see the bird on the other side, but you can see that woolly mammoth, and you can see on the right side the elephant that it became today. On the left, you see a saber-toothed tiger, and on the right, you see tigers as they are today, a little bit smaller. Those front teeth are definitely shorter. I think because my theory is because a lot of animals did grow smaller. You can see even the woolly mammoth is a little bit smaller. It probably didn't need those big front teeth to take down big prey anymore. As prey got smaller, it didn't need the bigger teeth. And you can see the lizard is now much smaller. It's, you see an iguana over there on the right side. In chapter 1, we saw how horses changed very slowly over millions of years and became the horses we know today. Another animal that changed is the elephant. Long ago, elephants had no tusks, no trunks or tusks, and were about the size of a pig. That is a huge difference there. Our birds today whistle, caw, chirp, cluck, and sing, sometimes beautiful flute-like songs. But the first birds long ago may have hissed like snakes. Many birds started out as small reptiles that ran on their hind legs. Gradually, their front legs sprouted a few feathers, and the little reptiles started jumping off the ground to catch bugs. Eventually, the front arms became wings, and they learned to fly. Whales started out 50 million years ago as an animal that lived on land. This animal was about 6 feet long, the size of a very large dog, and was a pretty good hunter. It had a long skull, lots of sharp meat-eating teeth, and it hunted for food in streams. A million years or so later, it was twice as long, still walked around on land, but looked more like an alligator and got all its food from the water. Within another million years, its front legs had become shorter. It walked around on land, but spent as much time swimming, pushing itself through the water with its hind legs. After another 10 million years, it had become a water animal. The front legs had become flippers, and the tail had disappeared. The nostrils had moved back and became a blowhole. Gradually, this animal became the whale we know today. That is a huge change. Now, the blue whale, and you can see the blue whale at the top there, that is the largest creature that's ever existed. It's bigger in the ocean than those Brachiosaurus or Brontosaurus ever were on land. And it started off as something, maybe the size of your large dog. Okay, that brings us to the end of chapter 6. Again, definitely do these activities at home. They're great. Looking at the time, I think we're going to go through the Q&A, and then I think we're going to take the last 10 minutes to talk about fossils. And so we're going to go through your chapter there.
Okay.
And then look at the fossils. Let's check through here really quick.
Okay.
Sarada says, I heard that birds are the actual descendants. Yeah, birds that are today definitely descended from dinosaurs that survived that mass die-off 65 to 70 million years ago. All right. Good. Lily asks, what is the book called? I'll hold it up for you again here. This is called Animals. Let me get out of screen share here. There we go. It's called Animals of Long Ago. This is available at heronbooks.com. Also, when you or your parent signed up for the webinar today, they would have gotten an email. In that email, there is a link to this book. There is a link to the learning guide that comes with it as well. Okay. Now for the thing I was most looking forward to today. Fossils, finding out about animals of long ago. Take it away, Diego.
All right. How do we know so much about dinosaurs and other animals that lived on Earth long ago? One way we found out is by digging in the ground to see what's buried there. Sometimes people find bones of animals from long ago and use them to figure out what the animal they belong to looked like. We have also found out things from old rocks or fossils. Dinosaur footprints and dinosaur bones have been found in rocks, for example. These bones and other signs of dinosaurs are called fossils. Rock fossils. Long ago, after a dinosaur or some other animal died, the soft parts of the body rotted away, leaving only the hard bones. These became covered with mud or sand that eventually hardened and turned to rock. The bones hardened too, but turned into a different kind of rock. Much later, the outside rock might wear away so the bones could be seen. Sometimes shells or tree trunks turn to rock the same way. Animal parts or plant parts that have turned to stone are called petrified fossils. Petrified means turned into stone, and we have some of those samples today. I'm going to show you this one. This is a petrified sample. On the inside there, right here, you can see a little bit of a shell. It has the outside of a shell there. Another one.
It's a little hard to see there. Sorry,
yeah. Another one. These are this is petrified wood. So you might have seen this before. It's pretty common around a lot of places. But
that's wood, huh?
Yeah,
it feels like a rock.
And you can actually even count the layers, just like a tree trunk. You can count how old the tree was when it died, and then they use something called carbon dating to figure out how old it was on much bigger time scales. Here's another piece of petrified wood. It's as hard as a rock.
Turned to stone.
Yep, turned to stone. Things can turn to stone with enough time. And here's another one. It's a clamshell. It looks like a clamshell, but it's actually just it's rock. It's totally petrified, turned into stone. Other fossils. Sometimes dinosaurs left their footprints in mud. Later, the mud hardened into stone, leaving rock with a dinosaur footprint in it. Sometimes animal parts and plant parts, like leaves, were buried in mud. The parts rotted, but prints of their shapes were left in the mud. If the mud turned to stone, then the print was saved in the rock. These are fossils too, but are different from petrified fossils. They are trace fossils. A trace is a mark left behind by something. So a trace fossil is something left in a rock that shows an animal or plant was once there. An animal track, a leaf print, and a dinosaur footprint found in rocks. These are all trace fossils. So before, let's see, with the amount of time we have left, I want to get into the activity.
Yes, let's do that really quick.
Okay.
We're going to define really quick the word paleontologist, which you see at the top of the page. They're scientists that look for fossils. They do research back through time. That's the way I like to think of it.
All right.
Okay.
So I'm going to give you one of the activities that's in the back of the book with the time we have left. This is to make your own fossil at home. So if you're like me and you have plastic dinosaurs at home, you can make your own fossil. So basically what you want to make is this, it's a salt flour type Play-Doh kind of stuff. And what you do, the formula is 2, and if you'll write this on the board behind me, that would be amazing. So you need 2 cups of flour. Okay, 2 cups of flour.
How far up does, there we go.
Yeah. So the formula is 2 cups of flour, 1 cup of salt. Now this is salt that I had in the lab, but you can use regular table salts just fine. So 1 cup of salt. So this is a really simple formula, and then about 3/4 of a cup of water. That's it. And you mix that up. So you throw it in a pan like this, and you mix it up with your hands, and you'll get a Play-Doh that looks like this. And the Play-Doh, you can do all kinds of fun stuff with that. One thing that I did yesterday to get ready for this is so this formula is something that you have at home, flour and water. You should have flour, water, and salt at home. But you take a lump of that, And then you take one of your dinosaurs, and let's see, where's the one I used here? I think this is the guy I used. And you press him in there like that. And then when you take him out, you'll have this piece of Play-Doh. You put this in the oven for about, get a parent to help you, but you can put it in the oven for about 200 degrees and it sets up like a fossil. So this is my own dinosaur fossil.
So from that trace there, from what's left behind in that rock that you found in your oven, you could figure out, let's see, was it this one? You could figure out about, well, at least a few things about this dinosaur from long ago here.
That's right.
Not everything, not exactly what was its color and, did it like to eat this kind of meat or that kind of meat or what its favorite movie was, but you could see its size, its shape. Yeah.
That's right. That's right. Yeah, there's a lot of clues that you can put together. Since that's what scientists do, is they try to put these clues together and figure out what happened to the dinosaurs and how long ago they lived, all these great things that we're learning about.
Yeah. Alette asks, how do paleontologists know how long ago dinosaurs existed? Excellent question. There's some really cool science that they can do, that they can test the rock, they can test the old trees or the bones that they find that is able to tell how long ago. It's a little hard to explain, but they test it and they can see how many millions. They can't say it was exactly 76,247,012 years ago, but they can see it was about 60 to 70 million years ago, or it was about this many million years ago.
Yeah, and that whole subject is called radioactive decay. Basically what it is how matter, how the stuff that makes up the rock breaks down over time, and it's its own science. Like we could spend days talking about that. But it's mostly, if you want to learn that subject, you need to learn math and chemistry.
Yes. Strata has on the making of our own fossils, how many minutes in the oven?
This is about 45 minutes. You could also just let it dry. So there's different ways to do it. Good. You can let it dry, but that'll take days and days and days. But if you want to get your sample done a little quicker, you put it in for 45 minutes. This one, because of its thickness, I ended up doing almost 2 hours at 200 degrees. Yeah, so 200 degrees for 2 hours.
Yeah. And again, all of this is explained and included in the workbook that you can download from the link in the email that you got when your parents signed up for this webinar. Two last questions here that we're going to go over. AJ asked, did all dinosaurs die at the same time? No. They died out over, and not all dinosaurs lived at the same time. We are closer in time to the end of the dinosaurs as the end of the dinosaurs was to the beginning of the dinosaurs. So it's been about 65 or 70 million years since the dinosaurs died out, and they were around for 160 million years. So yeah, so some species lived and existed at very different times from the others. At the end, whenever this whenever this disastrous event happened that wiped them out, they probably didn't die all at once. It probably took place over many, many, many years.
All right, and one other thing we have here is shark teeth.
Shark teeth.
Sharks are interesting because they've been around since the dinosaurs. So
does that mean sharks are dinosaurs?
Interesting.
You know what? In my mind, they are. All right. And Strata says, I thought sometimes amber preserves insects from long ago. Yes. All right. We're definitely going to go over time here just by a minute because I'm really interested in this and I want to show you something that I was reading about the other day. This is a piece of amber. Sap, leaks down a tree and drips down a tree and it falls onto something and it can encase, it can cover that thing, and then that sap hardens and becomes a fossil. We call that amber, and amber is gorgeous and it's beautiful, and we use it for jewelry nowadays, but every once in a while they find stuff in amber. You can see at the top there's an ant there, We can all recognize that ant. That ant is from, oh, what did they say this was? About 100 million years ago. There's something else in that as well. And this was a very exciting discovery. Some guy found this at a jewelry market. Some guy was selling chunks of amber, and this guy was a paleontologist, and he saw this and he's like, that's no ordinary chunk of amber. That's a dinosaur part right there. That is the tail of a dinosaur. And if we look in really close, those are feathers. So as they find more fossils and continue to put together the pieces of this puzzle that you were talking about, everything that they find, they learn a little bit more. It explains a little bit more. And something that happens when you learn more about something is you can find out that something that you thought was true is not so. You can find out that you were wrong. And a good scientist is really excited when they find out that they're wrong, because there's something more that they can learn. And that's super exciting to me. So seeing that this dinosaur from 100 million years ago was not fully a lizard, it did not have scales, but they see very clearly here feathers. He worked with a bunch of other paleontologists and scientists, and they were able to figure out what kind of dinosaur this most likely was. And I forgot to write down the name of it, but it's a cool sounding name. So the dinosaur, instead of looking like this with scales and stuff, maybe it looked a little bit more like that with feathers and kind of halfway towards a bird that we see today. You can see its arm is not big enough that it would have been able to fly, but you can see how this kind of thing might have turned into the birds that we have today. Okay, we are out of time here. There's so much more that we wanted to go over. Thank you, everyone, for joining in today. I'm going to take one last look at the Q&A here. Oops, here we go. All right. I'm afraid I lost the Q&A, but we are several minutes over time. Thank you, everyone, for joining today. We hope that you tune in later today and throughout the week as we continue these webinars.
Thank you.